Today we return to bond valuation. I have two questions. The first one is something we've looked at earlier as well, which is the relationship between the present value of a bond and the spot rate curve. In the second one, we return to the issue of valuing a bond in between coupon payment dates. So with that, let's get started. So here we're given a bond and its present market price along with a 6-month spot rate, and we're asked to calculate the implied 1-year theoretical spot rate. The best way to attack these problems is always with a timeline. So given that it's a $1,000 face value 11% bond, there's a $55 payment that occurs in period 1. And a final payment which includes the face value of $1,000, so it's $1,055. Now we know that the first payment gets discounted at 4%, and we're asked to calculate R, which is the discount rate of the second payment. The key thing here is to realize that the second payment is discounted over 2 periods. So the present value is the sum of the future discounted cash flows. And at this point, we simply have to solve this equation for R. R turns out to be 4.444%. And of course, the bond equivalent yield is 2 times that value, which is 8.89%. Let's look at the next problem. Now, this is a pretty straightforward problem. If you recall our basic graphic, which I've covered in an earlier video, the key hurdle point here is in calculating the value of small t, which is supposed to be the number of days since the last payment. Now here we're given 32 as the number of days before the next coupon payment. And obviously there are 180 days between coupon payments, given that it's a semi-annual coupon bond and a 360-day convention. So what that implies is that the number of days since the last coupon payment, small t, is actually 148. It's very easy to make this mistake and take small t as 32. So read the question very carefully. Now at this point, it becomes a very simple calculation. So we're going to compute the value of the bond as of the last coupon date, where the coupon payment is $6. There are 6 remaining payments. R is 3.5%, which is half the bond equivalent 7% given. And the future value of this bond is $100. So the present value turns out to be $113.32. We now compute the full price of the bond, which is the period adjusted value. So the full price of the bond is the value of the bond as of the last coupon payment multiplied by the future value factor for the period adjustment. Remember, we're using not the coupon rate, but the yield to maturity in calculating the period adjusted value. So the full price turns out to be $116.57. And of course, quoted is nothing but full minus the accrued interest, which is the coupon rate, not the yield to maturity, multiplied by the ratio of number of days passed to the total number of days in the period. And that works out to be 111.64, making C the correct answer. I hope your prep's going well. I'll be back soon with more videos.